Now we are going to consider the topic of static of rigid bodies, which listed in the book as the last chapter is static of rigid bodies. What do we mean by this? A rigid body is an extended body. There will be forces acting in different places. What are the conditions of equilibrium? The condition of equilibrium are, we're talking about static, right, of rigid bodies. We have the sum of the forces equals 0 and the sum of the moments about any point equals 0. These are the two conditions. Usually, in most of the problem, we start with the sum of moments first. Then we do the resolving. Right, except in one case where there is one force placed at one position, 1 point, 1 distance missing, then we do the sigma F first. Let us have the first example in the book. Example 1. It says there is a uniform rod. Okay, it is given here a uniform rod. In any problems of rods resting on the floor, we have two types of problems. Rod resting on the floor, therefore we have frictional force and normal reaction. And then we'll take the other example, rods which are pivoted or say, right, fixed at one point, and therefore we have here the action itself having two components. Let us take this first. This is the rod and resting on a peg here. The rod AB, right, the rod of length 10 meters, and since it is uniform, its weight in the middle, therefore the middle is here. Its weight, its mass 40 kilogram, about 40 G. It is 10 meter long, about 5 meter here. And then this is 5 meter. It is given that this is 2 meter here. And there's a 3 meters here. This peg, the smooth peg, so we have a normal reaction at the peg. We call it R. The rod resting on the floor, since it rests on the floor, there will be a normal reaction and a friction, and a normal reaction R. Since we have two normal reactions, accordingly we change the name of one of them, and we are going to call that force S instead of R. Now, as I said, we usually take moments first. Therefore, we are going to take moments about point A. We take moments about point A. This angle is given as 15 degrees. Therefore, the weight 40g times its perpendicular distance from the place I take moments to the force. Better than you say I resolve the weight. No. This is better to consider each force times the perpendicular distance. The perpendicular distance is 5 cosine 15 times 5 cosine 15. This is the clockwise moment. The anti-clockwise moment is the force S times 8. From this equation, you are going to get the value of S. 40g times 5 cosine 15 over 8. You will calculate that force and it will be 236.65. Next, we are going to do the forces. The forces, we are going to consider forces vertically and horizontally. But the force need to be resolved is S. So S will be resolved one component up, right? And one component horizontally. This angle 15, this angle 15. Therefore, if we say resolving horizontally. Resolving horizontally, we have F equal S sine 15 degrees. And this comes out to be 61.25. Then resolving vertically, we have R plus S cosine 15 equal 40g. S is resolved, this angle is 15. Therefore, the vertical is S cosine 15 and the horizontal is S sine 15. The horizontal equal F. The vertical plus R equal the weight. From this equation, we got the value of R. We got the value of R equal 163.41. Then we'll be asked to find the coefficient of friction mu equal F over R. Right, we calculate this, we comes out 0.37. This is one type of problem. A problem where we have a rod resting on a floor and resting on the other side on a peg. Usually you say the peg is smooth if there is only normal reaction at the peg. If you say the peg is rough, then we have to put also friction at the peg. Then it is resting on the floor. In the floor we have a normal reaction and friction. Let us go to the other example. The other example is similar to the first example. Yes, except that we are going to say that this beam is like a ladder resting on a horizontal floor and a vertical floor. Again, we have a beam resting on floors, so we have friction. Later we'll have the other type. Right, it says here that we have a ladder. Now, this is a wall. Sorry. This is a vertical wall. And this is a horizontal floor. And this is the ladder. This is the ladder. Now, right. Now, it says the ladder of mass M and length 3A has one end A resting on a rough horizontal ground. The other end B resting on a smooth vertical wall. Therefore, on the wall there is only a normal reaction. We are going to call it S. And here we have friction and normal reaction. Always a place we have a friction, I call the reaction R. Fine. Now, let's say a load of mass 2m is fixed on the ladder at point C. There's a load here is fixed at point C. A load of mass 2 mg, right? A load of mass 2m, even weight 2 mg. A load of mass 2m, therefore the weight is 2 mg at point C, where that distance is A. The ladder is modeled as a uniform rod. Now it says that the ladder is uniform. The ladder length is 3A. This means that the weight of the beam is going to be here. The weight of the beam is mg. If that distance is half A, and that is 1.5 A. Right. He said the ladder resting in limiting equilibrium, making an angle of 60 degrees with the floor. Find the coefficient, the same idea, find the coefficient of friction. The same problem. We take moments about A to get S, then resolving we get R and F. The same idea. Right. Now, we say we are going to take moments about A. The clockwise moments are 2 mg times the distance here is A cosine 60. 2 mg, its distance A cosine 60, plus mg is distance 1.5 A, yani 3 over 2A cosine 60. Cosine 60. This is a clockwise moment, equal S times this perpendicular distance. This perpendicular distance equal, this angle is 60, equals 3 sine 60. From this equation, we will get the value of S. got the value of let us calculate it. In actual fact, we have cosine 60 is half. Therefore, here we have cancel with 2, here by mg times a. Cosine 60 is half, right? Therefore, we get half, even this will be 3 over 4. 3 over 4 mga, and this will be mga. 3 over 4 mga plus 1 mga equals 7 over 4 mga. Divide by 3 sine 60, 3 sine 60 root 3 over 2. We got the value of S equal, right, 14 and 7 over 6 root 3 mga. Now, 7 over 2 is down there, will be 2, 6 root 3, yes. R resolving vertically, R equals 3 mg. Resolving horizontally, F equal S. Equal coefficient of friction mu equal F over R. This means 6, 7 over 6 root 3 mga over, by the way, this distance is 3a, there's a here, and therefore there's a here, the a will cancel. Okay, there's no a here. Okay, because the distance is S equal, that distance 3a sine 60, it is 3a sine 60. Therefore R equal F over R, and R equal to, right, this is F and R equal 3 mg. Mg cancel mg, therefore we got the value of mu equal 7 over 18 root 3. Yes, and this would be equal to 0.225. Okay, therefore we correct this. This is 3a sine 60. Right. Now, this is a question. Now we go to the other type of questions. The other type of question, right? I will give you an example of this type of question. Is this? It will be said that a rod is pivoted here, okay, making an angle of 30 degrees. And the rod is uniform, its length is 4 meters, Therefore, this is 2 meter and 2 meter. And the rod is of weight 10 kilogram, but this is 10 G. The rod AB is pivoted at A. At B, it is pulled up by a rope. That rope is making, say, 60 degrees with the rod. Okay? And we asked to find first the tension. What is the tension in the rope? We will find, to take moments, we need to get the perpendicular distance. This perpendicular distance is 4 sine 60. This is 4 meter, this angle is 60, perpendicular distance 4 sine. Therefore, we take moments about A. Therefore, the force at A is not included. We say 10G times 2 cosine 30 equal T times 4 sine 60. Ten G, right, times 2 cosine 30, this distance is 2 cosine 30, and this tension is T times 4 sine 60. From this equation, we get the value of T. T will be equal to 20G over 4, 5G. The tension T will be 5G. Four sine 60 and 2 cosine 30. Also cancel. Now, the next step is you are going to do, is going to be mentioned to you that this reaction at A has 2 components, X and Y. The reaction at A has 2 components, X and Y. And we are going to resolve the tension. This angle is 30, this is 30, but this angle is 30. But this is T cosine 30. And this is T sine 30. Therefore, we are resolving horizontally. We have X equal T cosine 30. You will get the value of X, 5G cosine 30. Resolving vertically, Y plus T sine 30 equal 10G. Y plus 5G plus 5G sine 30 is 0.5 equal 10G. Y equal 10g minus 2.5g, 7.5g. We got the value of x and the value of y. The resultant reaction R is the square root of x squared plus y squared. We got the resultant of the two forces. And then its direction, we say tan theta, the force has x and y, and this is the resultant R, and this is the angle theta. Tan theta is y over x. Therefore, we calculate the value of the angle theta. This is the other type of problem of a body which is pivoted at a fixed spot. If we have the problem of the body resting on a floor, we have friction normal reaction, and we take body resting on a floor and wall. Then we had the question of a rod which is pivoted at one point. We take the moment about that point first to get the tension in the rope. Then, by resolving, we get the components of that force R. Once we get its components, we can find the value of the force R and its direction. Right, this is the end of this chapter of statics. We go then to the last chapter, which was the previous chapter, which is work, energy, and power. Right. Now, in this topic, let me explain the topic right. Yes. Work, energy, and power. Now, let me explain the whole topic first. The topic is this: work, energy, and power. Now, work, when we have work, when we have a block, it is acted upon by a force. The force is F, and the block moved a distance D. How much is work done by the force? The work equal to Fd in joules, because the rule is saying that when we do work, we have to multiply the force times the distance moved in direction of force. If it happens that the force was inclined at an angle theta with the distance d, and there's an angle theta, then the work equal Fd cosine theta. Right, equal Fd cosine theta. Now, This is all about work. We come to energy. Energy, we have two types of energies. We have kinetic, we know of course that we have kinetic energy and potential energy. Kinetic energy is due to motion. Potential energy is due to position or shape. The energy, potential energy due to shape, is elastic potential energy, and this is not considered in this, in this syllabus. We are not going to deal with potential energy due to shape. Therefore, we have only the potential energy due to position. Kinetic energy is calculated as half mv square, and potential energy as mgh. Of course, we mean potential energy due to position, and we call it gravitational potential energy. Right? The other one is called elastic potential energy. Now, in problems where a body moves with no force act on it except its weight, and any body is going to move with no other force act on it except its weight, when a body moves and the only force is weight, then energy is conserved. And total kinetic energy plus potential energy equal constant. And it is said that energy, right, sometimes we say the gain in kinetic energy equal loss in potential energy, and vice versa. And we had problems like this in simple physics, right? But we remember that, like in projectile, also the energy is conserved. You project a particle, the particle moves up. It loses kinetic energy, it gains potential energy. The total energy is conserved. If external forces acted, then the work done by external force equal gain in mechanical energy. And mechanical energy means mechanical energy is a sum of kinetic energy plus potential energy. In some problems, there is resistance, friction, resistance, air resistance. Therefore, this equation is put in general form. The general form of this equation is this: work done by driving force equal gain in kinetic energy plus gain in potential energy plus work done against resistance. That includes air resistance or friction. Right. This is the general equation, the very important equation in solving problems, and relates the topic of work with the topic of energy. That the work done by the driving force equal the gain in kinetic energy plus the gain in potential energy plus the work done against resistance. For example, a body moves up a slope. This is the body, acted upon by a driving force D. The body moved up a distance on the plane. That distance is D. Accordingly, the particle moved up. If this angle is theta, this height h, then don't forget that sine theta equal h over d. Therefore, h equal d sine theta. There was a friction on the plane. The particle or the body was having a velocity here, u. Its velocity at the end is v. Then applying this equation, d times d is driving force times d equal half m v square minus u square plus mgh plus f times d, and where h is obtained from this equation d sine theta. This is the equation used. This is the application of that equation. Now, we come to the topic of power. Power is the rate of doing work. power equal, right, work over time. And power, of course, in units is watt. And we know that work equal force per distance over time equal force times velocity. This is a very interesting rule. In cars and trains, the power of an engine equal engine force times the speed of motion. This is applied for cars and trains. Very interesting equation. Power equal to the engine force, right, times the speed of motion. If you have a train moving in a horizontal level, train has a driving force D. There is a resistance to motion R. D minus R equal MA, and D times V equal power. If the train moving inclined plane and this is a driving force, we have resistance here, and we have here mg sine theta. Then the driving force minus R minus mg sine theta equal MA. And the driving force times the velocity equal the power of the engine. This is the idea of problems of this topic. The only thing is that I need to have proper examples, as the examples in the book, not all of it are really suitable, but this is the explanation of the topic. And this means this is the explanation, this is the end of the syllabus.